Alright, so this is our AP Chemistry Chapter 2 lesson video, Part 2, and we're going to cover sections 2.5 through 2.7. And again, this should be reviewed from Honors Chem, so hopefully you're finding all of this content pretty easy. So we're going to talk a little bit about the periodic table. The horizontal rows on the periodic table are called periods, and the vertical columns on the periodic table are called groups. So we have periods, we have groups. Elements in the same group have similar physical and chemical properties. Metals are on the left of the periodic table and nonmetals are on the right. So we have our metals, they make up the left, not hydrogen, the middle, the lanthanides and the actinides, and they go all the way up under the stair step. Remember, we have the stair step line that shows us where our metalloids are, and then our nonmetals are to the right, and of course hydrogen. Don't forget, hydrogen, of course, always seems like it's out of place. So, what do we know about metals and nonmetals? Well, metals are on the left in the middle of the periodic table. They are lustrous, which means shiny. They're good conductors, and they're solids at room temperature, except for mercury, which is liquid. Nonmetals are on the right of the periodic table. They are brittle, which means they crack or break easily. They're mainly liquids and gases, and they're poor conductors, except for carbon. Metalloids surround the stair-step line and have properties of both metals and nonmetals. So for example, this is silicon, so it's lustrous or shiny like a metal, however it's brittle like a nonmetal. So let's look at our first exercise. So it says, which of these two elements would you expect to show the greatest similarity in chemical and physical properties? Well, we know elements in the same group have similar physical and chemical properties, so I just need to see what's in the same group. So we have boron, calcium, fluorine, helium, magnesium, and phosphorus. Well, if you look at a periodic table, which if you don't have one out, go ahead and pause and get one out, you will see that calcium and magnesium are in the same group. Okay, so since they're in the same group, they will have the similar properties. So remember, it's the same group or column, not period. So next, it says, a biochemist who is studying the properties of certain sulfur-containing compounds in the body wonders whether traces of other non-metallic elements might have similar behavior. To which element should she turn her attention? Well, she's trying to figure out which element is behaving like sulfur, so she needs to look at something in the same group as sulfur. So when I go through these possibilities, we have fluorine, arsenic, selenium, chromium, and phosphorus. I can see, okay, well, selenium is the only one that's in the same group. So remember, elements in the same group have similar physical and chemical properties. Make sure you're trying some of these on your own. So it says, locate sodium and bromine on the periodic table, give the atomic number of each, and classify each as a metal, metalloid, or nonmetal. Well, sodium is on the left of the periodic table. Its atomic number is 11. And because it's on the left of the periodic table, it is a metal. Whereas bromine, Br, is on the right of the periodic table. Its atomic number is 35. And because it's to the right of the stair step, it is a nonmetal. So it's very important that you notice the difference in metals and nonmetals, because whether or not something is a metal or nonmetal helps a lot when we get into bonding and things like that, because it helps you figure out what type of bond would it form. It helps you understand periodic trends. Is it more likely to lose or gain valence electrons? Things like that. So, section 2.6, molecules and molecular compounds. So, we talked about these in honors. There are 7 diatomic elements. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Remember, you start at element number 7, which is nitrogen, and you make a big 7. So you'll see NOF, ClBrI on the periodic table. Then you just have to remember hydrogen. Remember, this means that they are paired up or diatomic whenever they are alone. Once they bond with something, the subscript can change. Molecular compounds consist of only nonmetals. So see, that's why learning about the difference in metals and nonmetals in the previous section is important. The molecular formula shows the exact number and types of atoms in a molecule, whereas the empirical formula is the lowest whole number ratio. Okay, so like if the molecular formula is N2O4, I can reduce that to NO2, which would be the empirical formula. Now, not everything can be reduced. Sometimes molecular formula and empirical formula are the same. So let's look at a couple together. So it says, write the empirical formula for glucose, a substance also known as either blood sugar or dextrose. The molecular formula is C6H12O6. Well, I can divide all of these by 6, so I get CH2O. That's all I have to do. All right, it says, write the empirical formula for nitrous oxide, a substance used as an anesthetic and commonly called laughing gas. Molecular formula is N2O. Well, I can't reduce a 2 and a 1, so the empirical formula is just what we start with. Okay, so it's okay for empirical formula to be the same as the molecular formula. Not everything can always reduce. But it's also important to reduce all the way. Like, for example, I can divide all of these by 2 and get C3H6O3, but that can still further be reduced. So you have to reduce as low as possible. All right, so it says, tetracarbon dioxide is an unstable oxide of carbon with the following molecular structure. So we can see it right here. They have left off lone pairs. What are the molecular and empirical formulas of this substance? Okay, well, I can tell the molecular formula just by looking at it. So C1, 2, 3, 4. So there's 4 C's, and then there's 2 O's. So that's the molecular formula. That's what the molecule actually looks like. So when I reduce that, it would be C2O. So I just look at my answer choices. Well, there's C4O2 and C2O.
Teachers, please pardon this interruption. Jeremiah Danley, you're needed in the front office. Jeremiah Danley, you're needed in the front office.
So remember, don't forget to be trying these on your own. Sorry about the announcements. It happens. All right, so it says, give the empirical formula for decaborane, whose molecular formula is B10H14. Well, 10 and 14 can both be divided by 2, and that will give me B5H7, which can't be reduced any further. Okay, so hopefully you got empirical formula. This should literally be one of the easiest things you've ever seen in your life. All right, so moving on to section 2.7, ions and ionic compounds. An ion is an atom that has gained or lost electrons and has a charge. So remember, we talked about how atoms can only be identified by the number of protons because different isotopes of the same element can have different neutrons. And if it loses or gains an electron and becomes an ion, then protons are the only particle that stays consistent. So a cation is a positive ion, which means it's lost electrons. And an anion is a negative ion, which means it's gained electrons, which I know seems backwards. Because when you see like a 2 positive, you want to think, oh, that means plus 2 electrons. But it's not plus 2, it's a positive 2. So that means it's lost 2 negatives. That's how it becomes positive. Because remember, they all start neutral. They all start neutral. So if they lose negatives, they become positive. If they gain negatives, they become negative. Sometimes calling electrons a negative instead of calling an electron makes it a little easier to remember that. So let's go ahead and jump on in. It says, give the chemical symbol including the superscript indicating mass number for the ion with 22 protons, 26 neutrons, and 19 electrons. Okay, so first of all, I have to identify the element. So I can only do that with protons. So I'll look at the periodic table. 22 protons is titanium. So remember, when we're doing our shorthand, we do mass number, atomic number, and if there's a charge, it goes up here. Okay, so first my atomic number is 22. Remember, that's just the number of protons. Mass is protons plus neutrons. Okay, so you have to add the 2 together. So that's going to be 48. And then we get the charge by comparing our electrons to our protons. So we have 22 positive particles. We only have 19 negative particles. So that ends up with a positive 3 charge or a 3 positive charge. You can write it either way. I will tell you in AP, I see the 3 and then the positive a lot more than the positive and then the 3. But you'll see me do it both ways. All right, so let's look at our next one. It says the ion of sulfur. So this time they told me what it was, so I know it's sulfur. That has 16 neutrons and 18 electrons. Well, this time they didn't tell me protons, but it doesn't matter. I can always use the periodic table. So sulfur is element number 16. So it has atomic number of 16. It also has 16 neutrons. So 16 plus 16 gives a mass of 32. It has 16 protons, but 18 electrons. So it's gained 2 electrons, so that gives it a -2 or 2 negative charge. Alright, so now what we're doing is using information from a previous video when we first learned how to do mass and atomic, and we're just adding the charge now. Alright, so remember, don't forget to be pausing this and, trying these on your own. So it says, in which of the following species is the difference between the number of protons and the number of electrons the largest? Well, y'all, the greater the charge, like the greater it is away from 0, so the absolute charge, it doesn't matter if it's positive or negative, the more electrons it's lost or gained. So like here, if it has a +2 charge, it's lost 2 electrons. If this has a -3 charge, it's gained 3 electrons. This has no charge, so it's lost/gained 0 electrons. This has a -2, so it's gained 2 electrons. And this has a +4, so it's lost 4 electrons. And so once I know that, it says which has the biggest difference between the number of protons and electrons. Well, remember, none of these have lost or gained any protons. Protons can't change in chemical or physical processes, so the greatest difference would be E, because it lost 4 electrons. And so again, you didn't actually have to go through and write all this out. You should have just been able to find the one that's furthest away from being neutral. It doesn't matter if it's in the positive or negative direction, because it didn't say, whether it had gained or lost. Alright, so remember, don't forget to be trying some of these. It says, how many protons, neutrons, and electrons does this ion possess? Okay, so we have selenium. So the first thing I'm going to do is I've noticed they did not give me the atomic number, but I can easily look at the periodic table. So selenium's element 34, so it has 34 protons. Okay, that's the easiest part to do. Alright, for neutrons, I of course can just subtract. So I do 79 minus 34, and so I got 45 neutrons. And then electrons. A neutral atom would have 34 electrons, because the protons and electrons must cancel. But this has a -2 charge. That means it's gained 2 electrons, so it has 36 electrons. Okay, so you should be able to easily, for atoms or ions, as long as you have a periodic table or at least the full version of shorthand, you should be able to determine easily how many particles it has. Alright, so it says predict the charge expected for the most stable ion of barium and the most stable ion of oxygen. Okay, so we learned how to do charges in Honors Chem. So remember, the first column forms a +1 charge, then +2. We skip the transition metals. They're all going to be positive, but they can have variable charges. Group 13 has +3. 14, carbon's group, has positive or -4. Group 15 has a -3. 16 has a -2. 17 has a -1. And group 18 has a neutral or 0 charge, because those are our noble gases. Alright, so again, this should be super easy. So barium is in group 2, so it's going to have a +2 charge. Oxygen is in group 16, so it's going to have a -2 charge. Okay, like you shouldn't even have to stop and think about one like this. Okay, this should be second nature from Honors Chem. Alright, so it says, although it is helpful to know that many ions have the electron arrangement of a noble gas, remember that's why atoms gain and lose electrons. They want to be stable like a noble gas. Many elements, especially among the metals, mainly the transition metals, form ions that do not have a noble gas electron arrangement. Use the periodic table to determine which of the following ions has a noble gas electron arrangement and which do not. For those that do, indicate the noble gas arrangement that they match. So, for this one, I need to see whose electron configuration matches a noble gas. Since I'm trying to find a noble gas, I'm going to do noble gas configuration. Alright, so I do titanium. It has a +4 charge. So titanium, the noble gas before it is argon. So I'm going to start with argon. Alright, and then I'm just going to finish it off. If you don't remember how to do electron configuration, you need to go back to the Honors Chem videos for Chapter 5. Okay, I'm not going to reteach electron configuration right now. Alright, so we have argon, and then we're going to have 3D2, 4S2. titanium's electron configuration. +4 means it's lost the last 4 electrons, so it lost this and this. So if I cut off this, that just gives me argon, so it has the same electron configuration as argon, because it's argon with nothing extra added to it. Alright, so let's look at manganese. And once you see me do a couple of these, maybe pause it and you try the last few. Okay, make sure you can do them. Alright, so we have manganese. So manganese, the same noble gas as before manganese, it is argon. But manganese is going to end with, let's see, 1, 2, 3, 4, 3d5 for S2. It has a +2 charge, so it's going to lose the last 2. So it's not going to have electron configuration identical to argon. It's argon and 3d5. So this one is not noble gas configuration. Okay, to be noble gas configuration, it would have to have a +7. Alright, so let's look at lead. Lead positive. I don't know why I even keep looking. I've already pre-worked all this out, so I didn't have to keep looking. Alright, so lead, its noble gas that comes before it is xenon, and it's going to end with 4F14, 5D10, 6S2, 6P2. So lead has a +2 charge, so I'm going to lose those last 2 electrons. So because it doesn't cut all the way back to xenon, it also does not have a noble gas configuration. So no noble gas configuration for this one. Alright, next we have tellurium with a -2 charge. So tellurium, the noble gas before it is krypton, Kr. Alright, and so then I do 4D10, 5S2, 5P4. But you gotta be careful. Tellurium has a -2 charge. That means I'm going to add 2 electrons. And so I know some of you are probably looking at this thinking, oh, okay, well, it's not noble gas. But the problem is we have finished off 5P6. So if you look at the periodic table, the end of 5P6 is just xenon. So it actually does have noble gas configuration. It has the same configuration as xenon. Okay, so that's where you got to be careful, is when you add electrons to finish off a row, that will also give you noble gas. Alright, so the last one is zinc +2. So the noble gas before zinc is argon, and then it ends with 3D10, 4S2. So of course it has a +2 charge, so I'm going to remove the last 2, and so this is again not a noble gas configuration. So no noble gas configuration here. Okay, and again, because electron configuration should be from Honors Chem, this hopefully made a lot of sense to you. Like I said, if you're struggling with electron configuration, you need to go back to my Honors Chem videos for Chapter 5 to get a refresher on that. Alright, so it says predicted charge expected for the most stable ion of aluminum and fluorine. So again, y'all, we just look at what group it's in. So aluminum is in group 13, so it's going to have a +3 charge. Fluorine is in group 17, so it's going to have -1. There's not even any need to predict it. You already know what the charges are. Remember, we've already learned this stuff. You might have to predict it if you were learning this stuff for the first time. Alright, so the charges for an ion can be found by looking at which group the ion is on the periodic table. So this is what I was just talking about. So we have +1, +2. These are various charges, but they're all positive. +3, positive or -4, -3, -2, -1, 0. An ionic compound, so we said molecular a minute ago, it's only nonmetals. An ionic compound is made between a cation and an anion, held together by an ionic bond, which is the transfer of electrons. So see, covalent bonds are sharing. We'll talk more about that when we get to bonding. They are generally a metal and a nonmetal. So molecular compounds are more than one nonmetal. Ionic compounds are a metal and a nonmetal because we need a positive and a negative to bond together. So it says, which of these compounds would you expect to be ionic? Well, we know ionic is a metal and a nonmetal. Well, these are 2 nonmetals. This is a metal and a nonmetal. This is a metal and a nonmetal. These are 2 nonmetals. Okay, so that's all you have to do to figure that out. Now that is a rule of thumb that we're using. Okay, there's always exceptions to the rules. Just keep that in mind. That's why you'll notice I said generally it's between a metal and a nonmetal. Then it says, which of these compounds are molecular. Well, molecular is more than one nonmetal. So these are two nonmetals. This is a metal and a nonmetal, so that would be ionic. These are two nonmetals. This is a metal and a nonmetal, so that would again be ionic. Okay, so hopefully super easy. All of this should be super easy. This section is just incredibly, incredibly easy. Please don't start getting the hint that AP Chem is really easy because of these. Again, you probably will not be lucky enough to get questions this simple on the AP exam at all. So give a reason why each of the following statements is a safe prediction. So it says every compound of rubidium with a nonmetal is ionic in character. Well, we know ionic has to be a metal and a nonmetal. Well, rubidium is a metal. So if it bonds with a nonmetal, we would expect it to be ionic. No, I'm not going to write it, I'll just click. So Rb is a metal, so if it bonds with a nonmetal, that should be ionic. Part B, it says every compound of nitrogen with a halogen element is a molecular compound. Well, nitrogen's a nonmetal, all the halogens are nonmetals. Molecular compounds are only made of nonmetals. So that does make sense. Both nitrogen and halogens are nonmetals, which would be molecular. Part C says the compound MgKr2 does not exist. Well, Kr is a noble gas. It's not interested in bonding. So, Kr is a noble gas, so it will not bond with other elements. They're inert. Part D, it says sodium and potassium are very similar in the compounds they form with the nonmetals. Well, that makes sense because elements are similar when they're in the same group, and they would both have a positive one charge. So Na and K are in the same column, so they have similar properties. And then part E, it says if contained in an ionic compound, calcium, which is Ca, will be in the form of the doubly charged ion calcium with a 2 positive charge. Well, we know calcium is in group 2, and group 2 forms a positive 2 charge. So calcium is in group 2, so it forms a positive 2 charge. So hopefully, again, all of this is very easy. So next we're going to move on to when we learn how to cross charges in honors. So again, this should be very easy and quick review. Alright, so it says write the empirical formula for the compound formed by aluminum and chloride ions. Okay, well I know that if aluminum is 3 positive and chlorine is negative, I need 3 aluminum. Now remember, you do not need to write the charges. I just write the charges in class so you can see where I got my subscripts from. Alright, here we have aluminum with a positive 3, oxygen with a negative 2. So I would cross my 2 down and cross my 3 down, just like that. Okay, so that way it's positive and negative 6. Remember, it just has to cancel. So remember, you don't need the charges when you're writing these. Alright, and then last, now we have polyatomic ions. So we have magnesium with a 2 positive, nitrate with just a negative 1, cancel out to make a negative 2, I need 2 nitrates. So don't forget, when you add a subscript to a polyatomic ion, it has to be in parentheses. And don't forget, hydroxide needs parentheses too. So if I have calcium and I have hydroxide, it doesn't matter that it doesn't already have a subscript. It's still a polyatomic ion and needs parentheses. That's one of the most common ones that people will miss, is they'll forget to put parentheses on hydroxide, which will then mess you up if you need to do something like molar mass. Alright, so don't forget to be trying some of these on your own. Alright, so it says which of the following nonmetals will form an ionic compound with scandium with a positive 3 charge that has a 1-to-1 ratio of cations to anions? Well, in order to be 1-to-1, that means no subscripts. If I have a positive 3, I have to bond it with a negative 3 charge element. So neon has no charge, so it can't be that. Fluorine has a negative 1 charge, so it can't be that. Oxygen has a negative 2 charge, so it can't be that. Nitrogen has a negative 3 charge. So see, the fact that they told me it has to bond 1-to-1, that's how I know it's nitrogen. Now it will bond with any of these right here. It's not going to bond with neon because of course that has no charge. But it will bond with O and F, but it won't be 1-to-1. So see, like if I took it and put it with F, I would need 3 Fs. So it would be a 1-to-3 ratio. Okay, so that's how you know. You got to read the questions carefully sometimes to make sure you're selecting the right answer. Alright, so again, make sure you're trying some of these. This is our last one for this video. So it says, write the empirical formula for the compound formed by these ions. And so they all 3 have polyatomic ions, but we're not going to freak out because nothing's hard about polyatomic ions. So I have Na with a positive and PO4 with a -3. So what do? I need 3 sodium, just like that. All right, next I have zinc with a +2 and sulfate with a -2. So +2, -2 already cancel, so you do not need to do anything with subscripts. Okay, don't change the subscripts if it already cancels. That's why I asked for the empirical formula, because it needs to be the lowest ratio possible. Then our last one, we have Fe with a +3 charge and CO3 with a -2 charge. So that means I need 2 Fe and I need 3 carbonate. So, like I've been saying in all the videos so far, this should be super easy and a review for you. If you are struggling, again, you need to go back to my honors chemistry videos if you're struggling, because that's when I taught this the first time, and so I go through much more detail when I'm explaining it. Okay, so don't worry, I will slow down once we get to the new stuff for AP Chem.